All right, we just got done doing limits for sine of x over x and 1 minus cosine x over x. And we found that the limit of the sine of x over x is 1, and the limit of 1 minus cosine x over x is 0. And all the proofs were right there. We're going to now look at derivatives of sine of x and cosine x and how they came up with these, because they don't really make sense until you actually see where it came from. So this is the definition of slope, y2 minus y1, x2 minus x1, which is delta x, using for this function right here. Now, before I go any farther, I'm going to put up a couple more trigonometric function identities. This is called the sum of two angles, or the subtraction of two angles, difference of two angles. You need to put this into your calculus toolbox as well, because this is a good chance that this is going to crop again later on anyway. So if we have two angles, which we call, instead of x and delta x, we're going to call them alpha and beta, because that's what the mathematicians have done. So the sine of the sum of alpha and beta is equal to sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Now, if we were subtracting those two angles instead of adding them, then we would subtract these two quantities from each other. And then for the cosine of the sum of two angles, again, alpha and beta, this is cosine alpha, cosine beta. And if the plus sign here, unlike what happened here, we're going to subtract over here, and this will be sine alpha, sine beta. And if it turns out that we're subtracting these two, finding the difference of these two angles, then we're going to add these two values over here. Because if you recall from the graphing of sine and cosine, they're exactly opposite of each other. Where one starts at 0, that's a sine, and the other starts at 1, and the value goes up for sine, goes down for cosine. So these are going to come into play, particularly when we're showing what's going to happen with finding the derivative of the sine of x and the derivative of cosine of x. So, in this particular case right here, this is my alpha, this is my beta. Okay? So we're going to look at the limit of this as x approaches 0, and we're going to focus on this quantity right here. We're going to use this to define this right here. So this becomes the sine of x cosine delta x plus cosine x sine delta x for this portion right here, minus sine of x, that's that right there, all over x2 minus x1, better known as delta x. Now, what we always tend to do is we tend to manipulate where everything is and then try to do something with it to eliminate variables wherever possible. That's generally the rule of most algebraic proofs or functions. So I'm going to try and get this sine x together with this sine x here. So I'm going to move this in between right here. So this becomes sine x cosine delta x minus sine x. And I'm going to separate that from this cosine x sine delta x. And that still is going to be all over delta x. Now, I can factor out a sine x right here. Okay? And so you get sine x times cosine x, delta x rather, minus 1. And this stays as that, cosine x sine, sorry, got the x, sine delta x, all over x, delta x. Now, the next thing I'm going to do is I'm going to separate these so that they become two different fractions added together with the same denominator, which we can do. So I'm going to make this sine x times the cosine of delta x minus 1 all over delta x plus cosine x sine of x, or delta x rather, over delta x. Now, this is all of the limit as delta x approaches 0. So, what I'm going to do next is I'm going to write this as a product of two fractions together, the cosine of x times sine of delta x over delta x. We'll come back to that in just a little bit. I'm going to do the same thing over here, where this becomes sine of x times cosine delta x minus 1 over delta x. Okay? Now, as the limit of delta x approaches 0, this is the same as having x as an x approaches 0, which means those are the limits that we just determined right before we did all this stuff. And we found that this whole thing right here equals 0. And we found that this thing right here all equals 1 based upon those two limits that we just did. When that happens then, this drops out completely, and this just gives us cosine x. So that means then that the function of x as the limit is x approaches, or delta x rather approaches 0. So the derivative of that function that we're dealing with here becomes just cosine x. So what we're saying here is that the derivative of the sine of x equals cosine x. Okay? So whenever we find a derivative involving sine of x, we just change it over to cosine x as its slope. So the slope at that particular point of x is going to be whatever the cosine of x is. Okay, now let's do the same thing with the cosine of x. The d's of dx of cosine x, so we're going to find out what the derivative of cosine x is. And so we're going to go through the same thing. So because we're going to be looking at the limit as x approaches 0, and now we're going to plug that into our definition of slope, which is that thing right there. We're going to replace the sine with cosine. So this is going to be equal to cosine of x plus delta x minus cosine x all over delta x by that definition. Well, so here's the deal with it, and that's delta x right here. So the deal with that is this. This is now a sum of two angles of a cosine. So now we're going to go over to this right here, and this is going to be our x, and that's going to be our delta x for alpha and beta. And when these are adding, then this is going to subtract. And so we're going to get this stuff right here. So that's going to give us then cosine x, cosine delta x. And since that's a plus sign there, when your minus sign here, sine x, sine delta x. So that's that whole thing right there, minus cosine x all over delta x. All right, so again, we're going to do a little manipulation, knowing this is going to be a little bit different because now I'm going to divide this into 3 parts with this delta x being in the denominator of each of those 3 fractions. So this becomes cosine x, cosine delta x, and I'm going to put the delta x here for the denominator, minus sine x, sine delta x over delta x here, minus cosine x over delta x. Okay? Now, so at this point, what I'm going to do is I'm going to factor out a cosine x out of these 2 right here. So I'm going to bring these 2 together. Cosine x, cosine delta x minus cosine x all over delta x minus, and this becomes sine of x times, now I'm going to put these 2 together, this is separate, I can put over 1 to make these separate fractions, but it's implied if I don't put it in there, sine of delta x over delta x. Well, we already found from the proof that we had at the very beginning of all this nonsense that this equals 1. So that gives me sine minus sine of x there. So we take a look at this, we're going to factor out a cosine x out of this. So we have cosine x times, and then take the cosine out of both of those, we get cosine delta x minus 1 over delta x minus sine of x. The next thing I'm going to do is I'm going to recognize the fact that this equals 0 right here. So that equals 0, which means this whole term drops out, and what I'm left with then is that the derivative of the cosine of x is equal to the negative sine of x. So this should be in your toolbox, and this should be in your toolbox.